Hello. In this video, I'm going to show you how to set up the environment for RetroShield for Arduino Mega and Teensy boards. First of all, I'm sorry this video was supposed to come out 6 years ago. I've been postponing it, but thanks to all the people who have been bugging me, I finally decided it's time to do this. So, what are RetroShields in 30 seconds? They're small daughter cards that plug into Arduino Mega and Teensy boards. And this way we can emulate the hardware platform in the Arduino side while a real processor executes code. I started this project in 2019. My goal is to do a daughter card for all the processors out there, 1-bit, 4-bit, 8, 16. So to use these cards, you have to set up the Arduino environment. Luckily, this is easy, and we have to go through 5 steps. We have to install the Arduino IDE, then we have to install the Teensy libraries, and then you have to download the RetroShield apps that I post on my Git repo. Then you have to program your board, and you have to open a terminal program so you can interact with the board. So let's start with the Arduino IDE. To install Arduino IDE, we have to open a web browser. I'm using Windows environment, but the setup for Mac OS is almost the same, thanks to Arduino folks. So let's go to arduino.cc, and you're going to go to products, software, go to Arduino IDE, and just download the latest one. Make sure to support these folks at some point. Okay. Let that finish. You can do a couple of things. I like to go, just as security, go to properties, go to digital signatures, make sure, it's signed before you click on it. And you can click on it. Agree. I do a local non-admin install, works for me. I don't plan on skipping any of these things because, frankly, installation is quick, seconds. So just please bear with me. All right. You'll see it will show up in here. Click on it. Yeah. Let it run. You have to allow a couple of things, and it's going to ask for your admin password. I set up my Windows machines myself as a non-admin password, so I will blur those, but just it's going to ask you a couple of. Okay. Let it finish. There's more. There's a couple of on-site ones, but it is what it is. Okay. Looks like it's done. So let's install Teensy and then we configure the Arduino. So go back to web browser. This time you're just going to search for Teensy and the PJRJ's website will come up. Click on the software add-on link. Now you have to copy this and add it into the boards section. So let's see. You have to go to File, Preferences, additional boards. I paste it in here. You click OK. I also make a couple of changes. So I make it a little bit bigger. I choose dark and I turn on all the warnings. When you click, it's going to download stuff. Now it knows about the Teensy board, so we have to go and install the Teensy board. So there's a couple of links. This will give you a folder view. This is the list of boards. This is the list of libraries. We have to visit both of them. So in here, type Teensy and just install the latest one. I really want to thank both Arduino and Teensy folks. They made it so easy for people to use microprocessors and microcontrollers. Um, for example, Teensy runs at 600 megahertz, has 1 megabyte of RAM. Imagine a Commodore 64, 6502 running at 1 megahertz, 32 or 64 Ks of RAM. It's just amazing. Yeah. Anyway, so we did that. The next thing we need to do is install a library. But let me show you that a little bit later so you know what happens if we don't do that. Library is called DIO2. Um, okay, so we're done in here. The next thing is we have to go and download the RetroShield apps. There are two ways to do that. The link is gitlab.com and then 8-bit force. This is my repo. If you scroll down, there's actually 3 repos. One is for hardware, one for Arduino software, and one for Teensy software. Hardware gives you, list of, it's more about hardware design, the design of this daughter cards and the design of the adapter board. Just like in the docs, you'll see a documentation that I collected for different processors. It's good to know. The hardware is a list of hardware PDF files. So if you need, for example, the schematic of one, you could go in there and you're going to see a PDF file. You open this, and this shows how the processor pins are connected to which pin on the header. I also copy this in the software folder as well. Just keep that in mind, yeah. Okay, so go back. There's two. Let's do Teensy because I want to show the 8008, world's first 8-bit processor. So you go in there. The process is the same for Arduino. Here you're going to see a folder for each processor. For example, the 8008, you click on it. There's actually 2 folders, one for Intellect 8 series of computers and one for Scalebell 8-bit, I guess, world's first 8-bit floating point basic by Mark. So that's our goal. And you have 2 options, like I said. One, you can download the code from here. You can zip. This will give you a snapshot of the software as of today. I like to clone it using Git. This requires you install Git. I'll just give you a link to it. So not the first one, okay? The git-scm. So one of the things you have to be careful about downloading stuff from web is you have to know where the source is, because anybody can, especially with open source software, anybody can clone these and like advertise these. I've seen it happen. There was like a hard takeover of another open source project, and then this taken over project got started pulled into the like Linux distribution and things like that. It could get messy. So open source is good, but there's stuff you have to be careful about because it's free, meaning anybody can do what they want. Anyway, so you download it from here and do that. I have already installed it on this computer, so we're good. So we're gonna do terminal. I normally make a projects folder, and then let's go back and say, do the HTTPS, copy that link, type git clone teensy, let it finish. Okay. I basically do all of them just to be done. Now, hardware will take a while because of all the PDFs for data sheets and sometimes software. Still not bad, maybe. Let's see how big it is. Might be a meg, or sorry, might be a gig. Meg, yeah. It's like I mean, I grew up in kilobytes memories. Now you compile something, it's like megabytes, you know. It's amazing. Yeah, it's like more than a gig. Almost there. Okay, done. So you'll get, 3 folders, basically what I showed you on the web. Um, so we got the apps. Let's see. I like to put a link in here. Go to Teensy 8008, Scalpel, and let's see. In here, you can just click on it, right click, open with Arduino IDE. Okay. So you should see all these different files. When you go to Tools, go to Boards, you're gonna see, the Arduino boards and then the Teensy because we just installed it. Click on 4.1. One thing you can do quickly is just to compile it. Hopefully it should, the first one takes because all the antivirus thing scanning all the files and bits in this. But the first one, after the first one, it should hopefully successfully complete. Okay. You're gonna see this, which is the Teensy uploader. Let me hook up my Teensy board and so the first time if you're programming a blank Teensy, you should just program the Teensy itself or the Arduino Mega itself. Don't plug in the RetroShield because if there's some leftover code and if that code is toggling the GPIOs that is in conflict with the processor, for example, if the Teensy is driving a pin that processor is also driving, there's going to be a short. It won't hurt, especially the Teensy board has level shifters in between. Even if one side drives high, the other side drives low, like it won't hurt it. But it's not a good practice. So just keep that in mind. So let me turn on my Teensy only. Once you turn on your Teensy, it should show up here. It says USB, so I click on that, and then I say programming. You saw the Teensy uploader programmed it, it's done. So to see quickly what's going on, we have to open the terminal, serial terminal, let it find it and connect. Now it connected, it does print. So the Teensy prints some information in the beginning. The software most of the recently I started having one software that detects whether it's Arduino or Teensy and then does things accordingly. So it prints out it's running on Teensy 4.1. Debug mode is not enabled, which is a lot of spew you don't want. Um, it's it's giving us 64K RAM. That starts from 0 all the way to FFFF, and some information about the credit for the 8008. I have to thank Mark for letting me use the software, the basic. You know, the other thing about open source is open source doesn't mean it's free to take. Especially people have copyright notices or they put in a lot of work. You know, open source they usually use licenses like the MIT license means you can do anything you want, right? If somebody, I can like take somebody else's um, and just change it, or don't even have to change it, put my name on it. I've seen that happen as well. So it's good practice to get permission, even though if it's open source and they give, it's still ping them. At least they know their, stuff is being used. Yeah. And then in this case, we don't see much more output because I didn't plug in the CPU card. So let me do that. And of course, I have to turn off the power. Let me plug in the. I'm going to do another video about the hardware, so don't worry. Maybe you watch that first. Okay. Everything's plugged in. Let's turn it on. Now we see, sorry, ready, different. And let's see, we can type list. There's two kinds of, endings. Most software I've seen uses carriage return. Some of them are okay with new line as well. The difference is new line will send 10 in decimal, and carriage returns or sends 13. Yeah, so in this case, we have to use carriage return. So when you type list, you see the output, which is this is a circle program that's on the, and let's do a quick run. Just say run. It's asking for a radius. To make it quick, I'm going to enter 5. And then it prints the area and the circumference and then plots a circle using stars. So this shows Arduino is working. We're successful. The Arduino serial monitor is not that good. So it's better to use a standalone one. And let me show you what I use. Okay, so let's let this finish. Okay, so you can scroll back. It's basically 8008 running at 500 kilohertz or 700 kilohertz and running this for us. And before I change to terminal, let me give you a couple of tidbits in the. So this shows you, you can enable this. It's going to print a lot of stuff. There are different files. CPU stuff, like resetting means, we set the clocks 1 and 2 low and then prepare the ready and interrupt or deassert ready and interrupt, things like that. So it's worth going through all of these. It's educational. You can see this is the beginning setup. As you can see, it prints a bunch of stuff we saw already. Sets up the board. There's a debug LED that blinks. If we're using soft UART, we have to configure that as well with the different bit rates and baud rates. And then we will assert the reset. And then for 8008, we have to synchronize with the processor. There's a sync pin that goes up certain times. So this is trying to sync to that. And once it does that, it's going to come out. It's going to let it run a couple of clocks to initialize the internal stuff. Keep in mind, I don't think, 8008 doesn't have a reset pin. So it does kind of some power on reset in the beginning, but after that, you can't. And the way you kick it out of reset is assert interrupt, and that's what happens. So we assert interrupt, which jumps to a certain location, and then the things, start after that. And the loop is basically there's a CPU tick, you just keep running, execute, execute, execute. In the meantime, in parallel, you listen for the soft UART because it's a bit bank, UART. If there's a debug activity, like when there's a serial communication, the LED blinks. There's a reset button. If it's pressed, we do things like that. So that's the whole idea. And you want to make something different, you just change code and recompile and run it. All right, so let's go to dedicated terminal, which is easier. For that, I use, on Windows, I use Teraterm. There's a bunch of other ones too. I think this is the good one. Yeah, Japanese, yeah, okay. So let's see. I use the standalone. And let's make sure. So you should see it in here. I just do this. I mean, yeah, it doesn't mean it's clean, but let's see. Yeah, it's a, like, yeah, it's another topic for another video. Okay. So let's see. For Teraterm, we open this, say open. Okay. Click on serial. You're going to see one, which is the Teensy. You click on it, it's there. Yeah, okay. So there's a couple of settings you should be aware of. The first one is serial port. Teensy is using USB, so you can set this to 150. It doesn't matter, it's fine. We use 8-bit, no parity. This is interesting. The way you do, this is where we use this is instead of typing a long program, you can copy paste it in terminal, and it's gonna, paste it as quickly as possible. And as quickly as possible means, you know, on the PC side, once the character gets sent to the other side, you just put another one, put another one, put another one. And the, sometimes this is done so fast, the processor cannot keep up. I put in code in Arduino side to make sure I tell PC to send me the next character when the processor read the character. Sometimes this is possible, sometimes not. So you try pasting stuff, and if it doesn't work, then you have to go in here and add delays in here. So for example, let's put 1 microsecond. 1 or 10 microsecond is fast enough or is enough delay for a microprocessor to catch up. So that's what you do. The other thing is that if you go to terminal, this is where you define what character to send when you hit enter. And options are, carriage return or line feed or both of them. You have to experiment this, and there's both a transmit side and a receive side. Um, just carriage return is okay for most of the time. So let's see. Let's run it in here, and we say 5. While it's running, I don't like that. Let me see. say we write our program in here. I put and because Apple One Basic complains if it's not there. So let's see if I can paste this into in here, right? So yeah, the program works. And let me see, let's do it again. Let me see what happens if I push the button on the Teensy. There's a kind of a reset button. So I pushed it and it disconnected and it got stuck there. So what we have to do is, let's see if we can power cycle. It's waiting for the uploader to re-upload the program. Okay, I just power cycled it. When I power cycled it, Arduino start from scratch, same printout as we saw earlier. And I normally also print some example commands. So list to see, reset sequence. Oh, that's not a command. Actually, I should remove that. Yeah. So scratch is to list a new one. There's already a program in here, so I'm going to do scratch list none, right? So let's now copy this, come over here and paste. It already knows what's in there. You click on OK, and the program's done. So let's run. OK. All right. Let's try another one. Let's remove this. OK. See if it fails. Now it's going to be as fast as possible. Also on Windows, remember this is not Control V, it's Alt V, because Control is used for the terminal itself. So keep that in mind. Okay, this also worked because I put in code for the 8008. So if I say run, see. This is a floating basic, so it prints floating numbers, but that's basically, let's see if Control C works. So Control C doesn't work. Usually when this happens, I'm not sure if it's supposed to work or not, but best thing is just power cycle, turn off. And term, when you reconnect it, if it was connected earlier, it'll reconnect and work. And you see the default program came back because I power cycled. That's about it. So if this way, you can do two things. You can play Arduino code and change the hardware, or you can, play with the terminal and do what you want to do. Let me show you another example actually, let's see. Yeah. So terminal, this is the basic terminal, just the characters, but you can also have VT100 or NC simulation or emulation, which means you can get colors and different activities. And Commodore 64 actually does that. It gives you a blue background. You can use the cursors to move up and down and left and right and things like that. So if you want, you can make the terminal side, the UART side, complicated. And one thing is you can use a terminal program to get the text output. You could also have a special link and have a custom app running, and they somehow communicate over UART to support graphics and audio and disk drives and floppies on top of the display. So all those things are possible. And that's where I enjoy doing that because, for me, I'm interested in the processor. I'm interested in, how many registers it has, like commands, instructions, what it does, and what I can do with it. Because at the end of the day, almost like PCs now and the computers in the past are very similar. They run programs that we type in. So have fun. Hope you enjoyed it. If you have any questions, feel free to bug me, send me a message. You should be able to find my contact. Anyway, enjoy your day and have fun. Bye.